I am Assistant Professor Urmi Shah from IT/ICT Department of LJ Institute of Engineering and Technology. In today's session, we will be moving ahead with chapter number 7, which we had started in previous session, that is Introduction to Digital Modulation Technique. So up till now, we have seen what is analog modulation, what is digital modulation, why digital modulation has been preferred over analog modulation, what are the key features, what are the applications of digital modulation, how digital modulation technique has been classified in three categorization based in variation of amplitude, frequency and phase, that is ASK, FSK and TSK. Amplitude phase shift keying, then we have frequency shift keying, and then we have phase shift keying. So these are the three categorization for digital modulation scheme. Let's start with today's session where we will be covering the following topics. So the topics which we will be covering in today's session are PSK, VPSK, balance ring modulator, which is further used for modulation purposes in digital modulation scheme. Then we will have QPSK. Then we will have a short difference or short understanding about what is bit rate and what is baud rate. So these are the topics which we are going to cover in today's session. So let's start with this session. So the first topic which we are going to cover is VPSK. Now, what is VPSK? It is nothing but binary phase shift keying. It will have two phase change for logic 0 and logic 1. For logic 0, it will have 180 degree phase shift compared to original carrier signal, and for logic 1, it will have 0 degree phase shift compared to the original carrier waveform. This we have seen in the previous session. So basically, in binary phase shift keying, you can have two phases, that is 0 degree and 180 degree. For binary 0 value, we will have 0 degree, while for binary 1, that is 1 degree. So this is the reverse case which we have seen in normal PSK. So this is the reverse waveform representation compared to PSK. This is binary phase shift keying. For logic 0, we will have 0 degree, and for logic 1, we will have 180 degree. So PSK and VPSK are reverse of each other. So the phase changes when the binary state switches, so the signal will be coherent in nature. So this is for VPSK. Now, if you want to have the constellation diagram means you need to draw the diagram where the logic levels, where your data signals will be represented in form of your phase chart, that is your constellation chart. So logic 1 will be represented on the right hand side and logic 0 will be represented on the left hand side whenever we are having these constellation diagram for VPSK, as you have only two logic levels. Further, what is balance ring modulator? Why it is used? This is the diagram of balance ring modulator. Balance ring modulator will have some supply in form of your message signal, that is PS. Then it will have a source from where you need to generate your carrier signal in form of local oscillator. So EC is nothing but your carrier amplitude. Then it will be processed with these 4 diode modulator circuit. This is nothing but bridge rectifier. The structure of bridge rectifier is having 4 diodes in cross form connected one after the other in one cycle, that is in positive half 2 diodes will be on, in the negative half another 2 diodes will be on. So this way the whole working of balance ring modulator will happen in form of the bridge rectifier circuit. Then we will have this TM016 as your filter circuit. This is nothing but the filter circuit. At the end, capacitor has been connected and it will handle the load. So output will be generated after the balanced modulator in form of modulated signal. So this balanced ring modulator has been used in various modulation techniques like this FSK, PSK for modulated signal generation. So this way the working of balanced ring modulator can be easily understood from the circuitry. TM016 is the transformer circuitry which is used over here. Transformer will do step up and step down of voltage with respect to the requirement of modulation scheme. Nextly, let's understand what is QPSK. Up till now we have seen that is PSK, VPSK. Now why there is a need of QPSK? If you have the data in form of 2 bits, if the number of bits involved in your data are of 2 bits, then your output logic levels will be 4, 2 raised to 2. We will have 4 logic levels, that is 0, 0, 0, 1, 1, 0, 1, 1. In VPSK we were having only 2 levels, that is 0 and 1. So the logic levels were also 2, 0 and 1. But here the data which is involved in your input is of 2-bit data. So 2 raised to 2, total 4 logic levels are involved, that is 0, 0, 0, 1, 1, 0, 1, 1. So now whenever you will apply the phase shift key for these following data, you will have a change of phase for all the 4 logic levels. So here the PSK scheme which is labeled as QPSK will have a quaternary phase shift. That means at every quarter interval there will be a phase shift. You can see over here in the waveform that is represented as DQPSK, that is nothing but differential quaternary phase shift scheme. At every logic level there is some slight phase shift. So this is nothing but QPSK. While in DVPSK you can see at 2 logic levels only you will have phase change. Otherwise it will remain same. Now let's understand how QPSK signal can be transmitted. This is the transmitter circuitry for QPSK transmitter. Over here you can have 4 logic levels as your input, 0, 0, 0, 1, 1, 0, 1, 1. Now what will happen exactly over here? Firstly, you will require a balanced modulator for generating the modulated signal. So in terms of 0 and 1, you need to first generate the modulated signal with respect to some phase shift. So 90-degree phase shifter has been applied here in the modulator section, and further your signal will be processed by the band pass filter, and in band pass filter further it will be passed on to linear transmitter, and then further BPF, that is your band pass filter, will generate the QPSK output. So this is the working or the transmitter block diagram for QPSK transmitter circuit. This way it will work based on the transmission of QPSK. We require 4 logic levels, so it will be generated by the 2 balanced modulator circuitry. First one will handle logic 1 related levels, and the last one, the below one, will handle related to logic 0 signal generation. So this way the QPSK signal will be generated in form of transmitted signal. Nextly, now coming to the constellation diagram. Here in the previous diagram you might be thinking that in VPSK the diagram is having on line 1 and 0. On x-axis only the diagram has been replaced. Now why this is like this? Because for logic 1 there was no phase shift, that's why it is on the positive x-axis, while for logic 0 there was 180-degree phase shift, so it is on minus x-axis. So this way the constellation diagram was created. I just wanted to show you the difference between VPSK and QPSK. That's why I kept this thing for the later. That for logic 1, your phase will be on positive x-axis as there is no phase shift. While for logic 0 we have 180-degree phase shift. So for logic 0, the diagram for VPSK is on negative x-axis. While if you see in your QPSK, then the diagram is in the 4 middle sections of your whole phase diagram. Why it is like this? Because between every logic level there is a 90-degree phase shift for x-axis and y-axis in QPSK. For first, let's take an example 1 1. Both the logics are positive. You have your phase over here, and for 1 0 you will have positive y-axis and you will have negative x-axis, that is logic 0 1. Then both are negative, that means logic 0 0. X and y axis both are 0. And for 1 0 logic you will have x-axis positive, y-axis negative. So it is in the fourth quadrant. So this quadrant based diagram you can see over here. Between two logic levels, the total phase shift is 90 degree, which was applied using QPSK transmitter circuitry. So this way the constellation diagram of QPSK can be represented with the help of constellation. Now, what are the digital modulation techniques? As we are ending with this session, or we are ending with the digital modulation techniques. So following are the techniques which we have learned up till now, that is ASK, amplitude shifting, FSK, frequency shifting, and PSK, that is phase shifting. But all these three modulation techniques are having involvement of digital, message signal and analog carrier signal. So this way we have studied the following digital modulation techniques. Now further, what is bit rate? Bit rate is nothing but the number of bits per second. How much bits per second you can transmit from one end to another end. So bit rate n can be represented as number of bits per second. The unit for bit rate is BPS, that is bits per second. Then baud rate is number of signal elements which can be sent per second. So for that we have unit bauds. In analog transmission of digital data, the signal or the baud rate is always less than or equal to the bit rate. That is S is our nothing but signal transmission rate is equal to N into 1 by R baud. That is R is nothing but number of data bits per signal element. And S and N are our SNR ratio parameters, that is signal to noise ratio. Nextly, let's understand this thing by having one example. So the question given over here is, an analog signal carries 4 bits per signal element. If 1000 signal elements are sent per second, you need to find the bit rate. So in this case, what is the bit rate given to you? It can transmit 4 bits per second. So R is your 4. Total signal elements S is 1000. N is unknown to us. So simply you can use the formula S is equal to N by R. By keeping the values of S and R, we will have the noise parameter, that is N is equal to 4000 VPS. So this way the simple questions can be asked for your numerical based questions in digital modulation chapter. So these things you need to refer. Then another example is given over here in terms of baud rate. Let's understand this example. So basically an analog signal has a bit rate of 8000 VPS and a baud rate of 1000 baud. How many data elements are carried by each signal element and how many signal elements do we need? So this is the question asked to all of you. Now firstly understand what are the given parameters to you. So the given parameters in this example are S is equal to 1000, N is equal to 8000. Now what is R and what is L? Those things are unknown to you. So for R calculation we can have using S and R parameters, that is S is equal to N by R. So R will be equal to N by S. So these things you can have calculated by using R is equal to N by S. So it will be 8000 divided by 1000. So R is nothing but 8 bits per watt. Now this you can calculate using the R, that is equal to log to the base to L. L we need to find, so it will be 2 raised to R. So 2 raised to 8, total we will have 256 signal elements. This is the requirement for our transmission. So this way you need to understand what are the simple parameters given to you, and you have to calculate based on the equations which we have understand for these digital modulation concepts. So following are the references for the topics which we have discussed today. Thank you so much for watching this session. In the upcoming sessions, we will have a brief comparison between digital modulation techniques, and then we will be moving towards the demodulation part of these ASK, FSK, PSK signals. Thank you for watching this session. Thank you.